Hello everyone, thank you to attend my session. Today we're going to talk a little bit about how we can integrate some AI into Jakarta. So my name is Jorge Cajas. I'm part of the Java user group in Guatemala. I'm one of the leaders. Also, I'm an Oracle ace, and I work for a consulting company called LangChain4j. So today we are going to see a little bit about the LLM. I'm pretty sure that you already saw like a ton of sessions about AI and how the LLM works. But I want to visit really quick some key concepts that we are going to need. And then we are going to have a demo using LangChain4j, using agents. But in this session, we are not going to build a chatbot. Usually, when we attend this kind of sessions or we see some tutorials, everything is about building a chatbot. So in this case, what we are going to do is that we are going to integrate LangChain4j in a Jakarta application. So you can see that you don't need like a new framework or a new application or new something to integrate AI. You can use your current stack. And instead of building a chatbot, we are going to see how we can make agents to work with tools with our backend in background processes. So let's start about the LLMs. Is there anyone that doesn't know what is an LLM? I think that pretty sure everyone knows right now. So let's do some analogy to understand the architecture that what we are going to build. So let's say that we are going to start with the CPU. Usually the CPU is something that receives some instructions and gives back some results. So in this case, our CPU is going to be the LLM. We are going to, instead of instructions, we are going to give it a prompt. And the response is going to be the result of that prompt after some reasoning and after some thinking. So this is going to be like the core for us, the CPU. But you know that the CPU cannot work just alone. We need to add some memory. Oh, I think it's not looking too good. Yeah, there was like a memory over there. So in this case, the CPU needs the memory. The LLM has something called the context window. The context window looks something like this. Basically, it's like the RAM memory. Is limited depending on what LLM implementation you choose. It's going to be between 4,000 or maybe a couple of million tokens, but depends on the implementations. If you are using, for example, OpenAI or Gemini, Mistral, Cloud, it depends on the implementation. But you need to know that the context window is measured in tokens. One token is roughly 25% bigger than a word. So, for example, if you have a document with 100 words, maybe you're going to consume 125 tokens, approximately. And you need to be very careful on how you manage this memory or this context window. Because on this space, you need to have like the system prompt that basically is how you instruct your LLM to behave. You don't want the LLM to just behave as a free begin. You want to say, you are going to be a business analytic agent that is going to do this and this and this. So you narrow the options for the LLM. Also, by default, the LLM doesn't have memory. Maybe if you are used to use ChatGPT or Gemini on the web, you see that has some kind of memory because you can like keep talking and talking with it. But when you are using the LLM with an API, the memory does not exist. So how we implement the memory? Basically, we send all of the messages from us and from the LLM each time that we are doing a conversation. So you can see that this history can take a lot of space because the bigger is the conversation, more tokens are going to be added if we want to keep that memory. So usually, you want to summarize that memory from time to time. Instead of sending the last 200 messages, maybe you can do like an extra call to the LLM and just, hey, summarize the last messages and try to make this compact. Or just forgetting some things from the beginning of the conversation if they are not relevant anymore. Then we have the prompt. This is basically the user message, what the user wants to ask for the LLM. Then we have the relevant information. Anyone knows what is the RAG system? Yeah. So basically, with RAG, we add some relevant information. Maybe it's about your business rules, maybe it's about some context, or maybe it's about some extra information that we need to give the LLM, so the LLM does not hallucinate or doesn't invent answers just because it needs to answer something. And finally, we have the response. So we need to take into account all of this on the context window to make sure that it's working. Depending on implementation, sometimes you just get an error, like a context window exceeded, and the LLM just not respond. I think that that's the best case. But there are some implementation that if you use exceed the context window, start to trim the context window. So for example, if you have 4,000 tokens context window and you send 5,000, maybe it's going to ignore the first 1,000 tokens and it's going to work with the rest. So let's be careful how we manage this context window. And for many of us, it's going to be like a reminder of how we worked on software like 20 years ago when we have very limited RAM memory. So it's basically the same, but applied to the LLMs.
Well, quick question, Phil. Can you repeat the difference between the system prompt and the normal prompt?
Okay, the system prompt is basically the instructions on how the LLM needs to behave. So for example, you are going to say, you are going to be a customer service agent that works for this company that sells air tickets, and your job is to be and this and this. So basically, the LLM is like very general, and when you set a role to the LLM, the options for the LLM is going to be more narrower, and it's going to behave better. So if you only send like the prompt, I want to buy plane tickets, the LLM sometimes can respond very professionally, sometimes it's going to be very casual, sometimes it's very different. But if you set the role with the system prompt, the LLM is going to be consistent on how it responds, and it's going to be better because you narrow the options, what kind of information needs to look before giving you a response. And the prompt or the system message is just the question that you want to ask to the LLM.
Question here. You said that one token is equal to 25% bigger than a word, and if your document has 100 words, it needs 125 tokens?
Yes. It's approximately, it's not exact 25% bigger, but yes, when you transform these tokens, it's going to be bigger. It's similar of, you remember base 64, when you made something into base 64, and base 64 is like a 33% bigger than the original file. This is something similar. When you transform the text to tokens, it's going to be a little bit more bigger than the original.
So the relevant information, would that be the, for example, embedding information into the model, or the data of the model is using?
Yes, the embeddings. So basically, the relevant information is like, in the system prompt, we say you are going to behave like this. On the prompt, we ask the question. On the relevant information, we send more context about the information. So for example, the LLM is good about thinking, is good about giving response, but the LLM doesn't know anything about your business rules. So you can embed some relevant information about your business rules, so the LLM can play with those business rules.
And when I embed those documents and input that information into the LLM, will that information be used by the LLM elsewhere, or will that be contained to my business application?
Remember that when you are using an LLM, you are going to use a third-party service. So it depends on your service. If you are using Mistral or OpenAI or Gemini, how your data is treated. And also depends if you are using like the free version or the paid version. But basically, this is like traveling from your local network to a third-party services to be used. So we need to be careful with that, unless you are using something like Olama or some in-house implementation for LLM. But yeah, this relevant information is going to travel outside your application and go to some servers.
So if you're using Olama, then that information will stay within your machine.
Yeah.
Just there. It's not going anywhere.
Not going anywhere because you have like a local. Yeah, but if you're using, for example, OpenAI, basically you are sending your information to the OpenAI service. If you are in the free version, basically you are paying the fee with your information. If you are on the premium or paid version, you have the option to say, forget anything about me and don't use my data to train your model. And most of the LLMs, commercial LLMs, has that option. If you are paying for it, you have the option to opt out of using your data for training purposes. So for example, if you are using this for medical records, you for sure need to be in a paid version when they are not using your information to train the models.
Yeah, one thing is related to information and other thing is how we got correct answer to stop hallucination. So yeah, that's why relevant information very person in a vector database. We store those information in vector database and then set context and send message to OpenAI or what kinds of services we are using, then we get proper response.
Yeah, so basically, as you said, the real information is to avoid the hallucinations from the LLM, because let's say that we are trying to make an application to sell tickets, plane tickets. The LLM, just like that, is going to be able to respond, but it's going to like hallucinate and made up some answers. But if you, in the relevant information, send what are your fares, what are your airports that you work, what are like your business rules, the LLM is going to take that into the reasoning and going to play with your business rules.
Yeah, I'm just giving you an example. Suppose I wanted to ask OpenAI ChatGPT to generate a query that give 100 records from particular table. Suppose one table name is employee table. So, then in that case, OpenAI generate query with table name, but that table name does not exist in my application. Yeah, that's why RAG is required. Then we refine more context, then it provides proper response.
Yeah, so basically you need to fine-tune the RAG process, because if you have like a very short embeddings, the context is not going to be enough for the LLM. And if you have a very large context, maybe you are going to waste tokens because you are sending more information that you need. And that's where the vector store comes in. We have the CPU, that is the LLM. We have the memory, that is the context window. And now we have the disk, that is going to be the vector store. So basically, this is how, when RAG comes in place, we are going to intake a lot of documents. It's going to be like a text documents, PDFs, CSVs, manuals, or any document that you have. There are like several implementations to intake that kind of documents. And you are going to transform those documents into chunk of text. And those chunk of text, after some math magic, is going to be converted in this kind of vectors that are usually 1,536 dimensions on that vector. But basically, what it does is that it's a numerical representation of the text chunk. So when you are doing some search, it's going to do some similarity search between your question and what you have on your embeddings or these vectors, and it's going to select the most similar results and embed it into the relevant information that we already saw. So how this works, basically we take the ingestion, the documents are transformed into chunks, the chunks are converted into embeddings that are those numerical vectors. Usually we want to save this into a database because it's a very expensive process to do all of this. You can use a pgvector or Redis or any other vector-related database. And when you are asking something to the LLM, you are going to do the retrieval. That basically is you are going to take your question or your prompt, and you are going to do some similarity search with your embeddings on your database. You are going to take the top 1, 2, 3, 4, 10, depending how you tune your RAG process. And then you are going to send the request to the LLM with the system prompt, the history, and the relevant information that you selected from this retrieval process.
So where is vectoring happening in this process?
What?
Vectoring, where is it happening?
Vectoring is when we convert from chunks of text to embeddings. So basically, the vectoring is called embeddings.
Laying difference of retrieval. So you see retrieval, index is defined when query to, then your that have two ways. One is ingestion process and other is response process. In case of ingestion, before querying and all those kind of things, we ingest all those data to vector database like feed, what document file we have, and then we start response to our query. And then it take, because when we ingest, then all data would present into the vector database, and when we do query, the response would automatically come from there and set context accordingly.
Yeah, so basically it's first the ingestion, we convert the documents into chunks, the chunks into embeddings or vectors, we save that in the database, and when we are going to ask something to LLM, first we query this database to get the top results or similar results, and we embed those results into the relevant information, and we send the information and the question to the LLM, and then we got a response. So we have like the CPU, the memory, the disk. We have like a computer, but we need some programs for the computer to be useful, because just the computer there does nothing. And for us, the programs are going to be tools that are basically some functions or some methods that we can share with the LLM, so the LLM can make use of our backend. So for example, you can send a prompt to the LLM that says, you are going to be a poet of the 15th century, and you are going to write a poem of this topic, and then send it by email. So the LLM is going to be able to behave like a poet. It's going to be able to write a poem about the topic, but the LLM doesn't know how to send an email. But the LLM is going to see on the relevant information that there is a function that can invoke, and it's going to like ask back to you, hey, I already have this poem, I need to send it by email, and I see that you have available this little function to send it by email, so please invoke it with these parameters. So basically, it's a way to extend the LLM capabilities with your own business rules and with your own backend. So that's how we are going to see the little demo today. And that is where LangChain4j comes in place. So basically, we have like a lot of options to use LLMs. I said we have OpenAI, we have Gemini, Cloud, Mistral, you have a Llama, and there's going to be like a lot of them every year. So LangChain4j, you can see it in a way, like analogy, like the ORM. So basically, you have like ORM, like JPA or Hibernate, and you put like a driver for MySQL, for Oracle, for Postgres, or any other database. LangChain4j is going to be something similar. So LangChain4j is going to provide you some standard APIs to interact with the LLMs, and what you need to do is just place the connector and do the configuration for the specific LLM. How that works, they have something called the agents that basically is a way to orchestrate the conversation between your backend and the LLM. So for example, you're going to do the task, write a poem and send it by email. That's going to be sent to the LLM. The LLM is going to do some thinking, some reasoning. It's going to ask your backend or your tools about sending that for email. That tool is going to go to your backend. It's going to send that by email. And that's going to go back to the tool, say, OK, I already sent it. And the tool is going to say, OK, LLM, I already sent it. If you have more complex processes, this is going to be like a conversation between your backend and the LLM. Back and forward, going between the LLM to the tools to the backend and responses. So the agent basically is a way to orchestrate all of this conversation automatically, and you just need to like provide the tools for the LLM. So any question on this? We are going to see this in action. We are going to have some demo. We are going to use LangChain4j, Jakarta E, and OpenAI as the LLM. So one takeaway of this session is that even if that LangChain4j is not part of the specification, plays very well with Jakarta. You don't need to rewrite your application. You don't need like a new framework. You don't need something from scratch. If you already have an existing application, you can use LangChain4j to build something. So for the demo, we are going to use a Jakarta AI project. I use this Payara starter. Payara is a server that is a Jakarta AI compilant, and you can run Jakarta AI project there. I choose Payara this time for this demo because they have this really nice starter where you can create the project with the dependencies. You want Jakarta, you want microprofile, and also they have this diagram builder. So basically, if you need to do some prototype or some demo like we are going to do today, that's going to generate all the tables for the database and the services and the resources and even some web pages so you can interact with your prototype. And it's pretty nice because it's also using some AI. So I can say something like add an offer table for customers. And it's going to generate new tables and new diagram. So it's pretty nice. I can suggest you, at least for prototyping or for trying something new, this Payara starter is pretty nice. So,
like how will that knows what kind of field should be present in customer table?
sorry?
You are saying add an offer table to customer. Then customer table already exists?
This one?
Customer table?
Yeah, it's only a diagram.
Yeah, this is only a diagram. But it's going to generate, for example, all of these models that are JPI models. And also it's going to generate the resources. So basically, are like your API.
SQL diagram as a prompt for AI to generate the codes.
Yes.
But the starting point was you wrote that SQL diagram, the ER diagram. Yeah.
Yeah. So I took one of the existing diagrams. I just extended it with some prompts. And based on this diagram, this Payara starter is going to generate the code for the entity models, for the resources, for the services. So it's pretty nice because at least for prototyping, it's pretty good. And what we are going to do today is that we have some customer management service. And every time that you receive some feedback from the customer, that basically can be like a good feedback, bad feedback, or a request of products that can, in real life, can come from some call center annotations, from some form on the website, for some email or any channel. You are going to save that feedback. And in the background, we are going to fire some events. In this case, we are going to use some CDI events. In real world, you can use like topics from AWS and fire this synchronously with some lambdas or something. And after you receive the feedback, we are going to set a process in background to ask the LLM to analyze the feedback. And depending on how it is sentiment, if it's a request, if it's a positive feedback or a neutral or bad feedback, it's going to take actions like set up a follow-up call for the customer or offer the customer a new offer because the customer was a little bit mad, or create a new business opportunity. So this is the diagram that we're going to work today. Basically, we have like a business opportunities, task that we need to execute for the customer, like calling or sending emails, the feedback that we receive from the customer, offers that we can assign to the customer, and a history of offers. So let's start with something that we already know. We have the feedback entity right here. You see like has an ID. Let me do it a little bigger. Has some comments, some feedback date, and a reference to the customer. But I already have like this entity listener. So every time that this get persist, a new one is gonna fire this event. So it's gonna be working asynchronously on the background, that's a background process. This event publisher is a simple CDI event. You look at this, this is like a Jakarta Enterprise Events. In real life, you may use something like RabbitMQ or SNS or something from AWS, but this is just an asynchronous event. If you look, I'm not using anything weird here, just Jakarta. if we see like the dependencies, I only have dependencies to the Jakarta APIs, to microprofile because I wanted to use microprofile config, LangChain with the implementation for OpenAI, and the logger. So this is a pretty simple project, only using Jakarta and microprofile. So we already have like the entity listener that is gonna fire the events. Then we are gonna do the configuration for the LLM. So first of all, I'm gonna have like this configuration. If you see, it's pretty simple, just a lot of properties. The IP key, the model name, the temperature, the timeout, the tokens, all the configuration that OpenAI API requires. This is coming from the microfile config, that basically is this, that can be this text file or can be some environment variables, something simple. Then I'm gonna configure the service. If you see, it's just like application scoped CDI bin. So I'm just creating something that I can inject into my application. And basically, I'm gonna select that I'm gonna create an OpenAI chat model. I'm gonna pass the configuration that I show you from microprofile. Then I'm gonna build my agent that basically is like an AI service with this OpenAI agent. I'm gonna show you that in a moment. With chat language model, this is basically just the configuration of the agent. And I'm gonna have this method that is gonna process the feedback. How the AI service look, the agent, again, is just an interface, nothing weird here. I'm gonna have this method that is like the process feedback that is gonna receive the customer ID and the feedback text. And I'm gonna annotate it with a system message. You see, I'm setting the role of the LLM here. You are a business analytic trying to read feedback and requests for customers. You need to categorize the feedback from customers and decide if you need to take an action. If the customer is a customer request, you need to create an opportunity of business to sell something. If this positive or neutral feedback, you are going to create a task so we can send an email of thank you to the customer. Or if it's a negative feedback, you're going to assign an offer to the customer so the customer can be a little bit more happy. And we are going to create some tasks to make a follow-up calls. So basically, this is how I want this agent to behave. Just for the demo, to keep it simple, I write this big prompt here with all the business rules. But usually, you don't write these big prompts because you have the RAG process to include this information into the prompts. And then the user message is just like the text that we got. So how do we create an AI agent? It's just an interface with a method, and the method is annotated with the system prompt and the user prompt. It's that easy. So on the event consumer, I'm consuming the event that I fired on the entity listener. I go to the processor, and the processor just call the AI service that I just showed you. So you see, I'm not using anything weird, anything strange, just plain CDI bins that we know how to use in Jakarta. So any question on this? No?
In the opening slide you had, was it research or something? There was a question about it. Where is that applied in the code? If you go back to the slides real quick, I'll show you. Keep going. One more.
I think it was the first one, right?
Yes, opening slide, right? Yeah, relevant information. What in the code corresponds to relevant information?
For the simplicity of the demo, I didn't include the RAG process, but part of the relevant information
Information is the RAG.
Yeah, it's the RAG, but also the information about the tools that the LLM can use to interact with our backend.
So the tools, instructions that bind the agent, the annotations of where they bind the agent to the tools and the parameters around which the agent might use those tools?
Yeah, so basically it's going to include like a list of functions that say, oh, this function is called create opportunity that needs these parameters, and it's going to be used for this. Let me show you. So I have like the tools. If you see, I have like the services that has like all of the CRUD functions for all the entities. And then I choose how to expose some of them. So this is a customer tools. Again, it's something like the use of CDI being application scoped. I injected my services here. And to create a tool, it's as easy as just create a method with your logic, annotated with the tool annotation, and put some description so the LLM know how to choose the right tool for the work. So this annotation, this tools annotation is going to be converted into a list of functions that is going to be sent as part of the relevant information. So the LLM knows that there are some functions or tools available to interact, and is going to make use of them. So for example, this is get available offers, get a list of all the available offers to choose from. So the LLM knows what kind of offers can assign to the clients. Opportunity. Create an opportunity for the provider customer ID. The name should be a short description, and the close date value must be provided in the ISO format. So basically, I'm just writing like kind of prompts, so the LLM knows how to use these tools.
Yeah, those were wired in the initialization of the agent, right?
Yeah.
Those are past tense or thing.
Yeah. So all the tools are just like this, just methods that are annotated with the tool annotation and some description. So if you look back of the agent, I send in this prompt something like hints about the tools. So for example, if you think that this is a customer request, you need to create an opportunity of business. And if I go to the opportunity tools, create a new opportunity for the provider customer ID. So those are the kind of hints that the LLM will use to choose the right tool for the work. So let's see if the demo works, because demos sometimes can be tricky.
In your experience with regards to creating those tools and the prompts, like the hints you call them around them, if they're not distinct enough, is there sometimes problems with the AI, or typically the parameters are enough to differentiate them?
Yeah, you need to be very specific. So for example, sometimes I do this. The order of the parameter is customer ID, name, amount, and close value, because sometimes the LLM will mix them if there are like a similar functions. So as part of your description, you can add like this kind of hints.
Sure.
Okay, let me run the project. Okay, project is running. You see it's like a Payara. All of this was already generated by the Payara starter, so I didn't write any UI code. And just let me seed this so I can generate some. Okay. So I just created some customers and some offers, so you can see like different data here. And I'm gonna write some feedback. So I'm gonna say, I need to buy 100 cases for iPhone 15. This is gonna be treated like a business opportunity. Okay, that is today. I'm gonna save. And I'm not sure if you can see it, but here is gonna be like the response, opportunity created. And this is like the response. I have created business opportunity for the purchase of 100 cases for iPhone 15. The total is gonna be $1,000. And additionally, a follow-up call has been scheduled for the next business day. And here is the information about the tools. So the first tool that was called was functions create opportunity with these arguments. There is another tool, functions create task, that was called with these arguments. Follow-up call regarding the purchase of the cases. So basically, the agent already orchestrated the conversation between the LLM and my backend, used the tools, and that created this opportunity.
Sorry, one feedback. Yeah, so, you are selecting feedback from your list. So, is it possible customer directly put their feedback in?
Yeah, I mean, this feedback can come from call center doing some annotations, some from email, of however you want to ingest. At the end of the day, as long as you have like the record in your database, it's gonna be picked by the listener and trigger all of this process. So the user can have a chat box, but the idea of this session is not just a chat box, a chatbot. But yes, the user can write something. I'm gonna do a demo for that. But in this case, I did like a business opportunity. You see that the record was created in database, and also the task, a follow-up call regarding the purchase of 100 cases. Let's write some negative feedback. So I purchased your product and it was faulty. This is the second time this happens. So basically, this is some feedback. As I said, how you ingest this information is up to you. Call center calls, some emails, some form in your website, or any other way. I'm gonna send this. So this is gonna be like a negative feedback. So I expect it to create something different this time. So you see here, this time, what it is that assigned an offer of the 10% discount. Reason, the customer received a faulty product, offering discount to retain the customer. This was reasoning of the LLM, and create use different tools. Like this time was assign offer to customer, and also a task for a follow-up call to inform the customer about the offer assignment. If I go to the offer history, you see here, the reason is because the customer received a faulty product. This is what I put on the feedback. And if I go to the task, now I have a different task, follow up to inform the customer about the offer assignment. So you see, I kind of instructed the LLM to behave like a real world agent, took the decisions and executed the action depending on the kind of feedback that I was provided. So at some point, you can say that you can, with the RAG process, upload your business rules, turn up your setup, and maybe instead of like building a lot of logic into your application, you can rely on the LLM to take the decisions about the flow of the data and choose this method, choose this function, or choose this way to do the things and execute your business logic. So in this case, we are using the LLM as a background process, not just like a chatbot. So, any questions? No.
Would you say the agent does more to execute the tools and less than, say, adding embeddings to the request? So, for instance, you have that customer. Would an agent go out and get the customer information and add it to the prompt, or would it?
Yeah, so in this case, I used the agent or the LLM to analyze the text. Usually you have like a real person analyzing all the reviews and saying, oh, this is bad, this is neutral, this is good. I'm going to give an offer, I'm going to call this client. So in this case, I use the LLM just to like analyze the feedback. You can say that this is like a big company that receives thousands of feedback messages a day. This is a way to automate this. And also the LLM was like smart enough to take decisions about assigning an offer or just a follow-up call or identifying a business opportunity. So this is just a way to automate some tasks on it.
And I like that, but I'm trying to understand. So with the RAG, you put the RAG in the system prompt.
Oh yeah.
But
Instead of the RAG, I just put like a lot of this.
But I'm trying to understand the agent. Is it only for executing actions after the LLM has made a decision, or is it capable of also self-identifying information and bringing it in?
Okay, let's suppose that I have the RAG process in this demo. I didn't include it to make it simple, but let's say that we have the RAG process, and we are going to ingest like a lot of documents, maybe the manual of how you train your employee. So before we go to the LLM, what is going to happen is that the feedback is going to be converted into an embedding, into vectors, and then it's going to do some similarity search between the information that you already ingested and is already converted into vectors. It's going to select the top results, and then it's going to add it to the request to the LLM, and all of that is automatically. So
but let's pretend that you have all of that, and now I'm an individual customer. How do you know that I actually bought those products to get a 10% discount? Is kind of what I'm saying.
yeah, you can add like more tools to verify if it's a real customer. You can like if the customer already put the order number in the feedback, you can like verify that. If not, you can instruct your LLM to say, if the order number is not there, create a task for sending an email, follow up with this client to verify if it's real. So basically think about the LLM like you're training a new hire, and you need to explain him everything. The same is with the LLM, as you need to explain what to do in different situations. For example, in this case, if the order number is there, maybe there is a tool to validate that order number. See, the order number is not there. We don't know if it's a real client, so we need to do like a follow-up email asking for more information. So, but all of that happens automatically because the agent orchestrates the RAG retrieval, the tools using the request to the LLM. So all of that happens just in background, like the conversation.
And that's all managed by the agent.
Yes.
Okay, perfect. Thank you.
Any other question?
Is this demo available on GitHub?
Yes.
How much of that was like the balance between Jakarta E and LangChain4j, LangChain4j? How much of it was used by what?
Okay, so basically all the application is just a Jakarta application. You can see on the that I only have like these two dependencies, Jakarta and microprofile, because I used microprofile config. And I use LangChain4j as a plain CDI bin. So I just created the service as an application scoped and injected that into my processor. So basically, LangChain4j plays very nice with CDI bins. You don't need to do some magic or some setup or something extra. Just expose it as a CDI bin. So the idea of this demo is that if you already have a Jakarta application, you can use LangChain as a plain CDI bin, and you don't need to build something from scratch. You don't need to do something weird or choose another framework or another language. What you have is ready for integrating LangChain4j as a plain CDI bin.
So basically, LangChain4j gives you those add tool annotations that you can
Yes.
use your app.
Yeah, basically what LangChain4j did for me was the tools, the ability to create my prompts with user message and system message, and configuring what AI model I'm going to use. But all of that was made as application scoped CI bin.
So when you added those comments in the UI, I'm guessing you have some sort of endpoints in here?
Yeah, so for the feedback, this is a plain JAX-RS endpoint. So the endpoint receives the feedback, then the endpoint uses the service that basically is create and they get saved into the database with JPA. And how I made it asynchronously, I put a feedback entity listener into the entity, and every time that I got something persisted on the database by JPA, I just fire an event.
Got it.
And this event is a CDI event. So,
Feedback is feedback from the agent. Feedback is feedback from the agent, correct?
feedback is what you receive from email, from the call center, for something. It's what the customer said to you.
Which in
Oh,
this
okay,
case,
sorry, yeah.
which in this case was what you entered.
What I enter on the yeah. So let's imagine that you have a call center taking calls every day, and they are like with the profile of the customer, and they put some annotations. With an entity listener, you can just intercept those annotations from the existing system, fire an event, and make all of this asynchronously. In real world, maybe instead of a CDI event, you are going to publish to a RabbitMQ or to AWS SNS as a topic. Maybe this is going to be triggered by a Lambda or something else, but can be used also like this. Any other question?
Thank you.
Thank you.
Okay. Thank you very much.